In DTF production, soft hand feel is often considered a premium indicator. Many buyers associate softness with high quality. At the same time, some operators observe a pattern. When prints feel softer, colors sometimes appear less vivid. This leads to a simple assumption: soft equals weak color, strong color equals heavier touch. This assumption is not entirely wrong, but it is incomplete. Softness is primarily influenced by how much transferred material retains on the fabric surface. Less retained material means lower surface stiffness. Lower surface stiffness usually feels softer to the hand. Color depth, however, is a visual density effect. Visual density depends on how much ink stays concentrated within a defined area. When ink retention is intentionally limited to improve comfort, optical density is often reduced. This is a structural relationship, not a random defect. During printing, ink spreads across the coated surface. Coating chemistry controls absorption rate and anchor depth. To achieve softer prints, some systems reduce ink stacking. Ink layers become thinner. Thinner layers improve flexibility, but thinner layers reduce light absorption. Light reflection increases. When ink mass decreases, higher reflection reduces perceived color richness. This is an optical response, not necessarily a pigment weakness. Powder bonding also influences perception. To maintain softness, powder application may be minimized. Lower powder volume reduces total melt mass. Reduced melt mass improves fabric drape. However, powder contributes to color framing. When melt coverage decreases, edge definition may appear lighter. Under certain lighting angles, this visual shift is stable, but under retail lighting, it becomes noticeable. Lighting conditions change perception. Under warm indoor lighting, lower density prints may appear flatter. Under natural daylight, differences may be less obvious. Fabric base color also interacts with ink thickness. On darker garments, reduced ink mass show faster visual fading. On lighter garments, the same print may appear acceptable. Therefore, softness-related dullness is context-dependent. When operators notice weaker color, the first reaction is often to increase ink load. Increasing ink load raises density, but it also increases stiffness. Some attempt double pressing. Double pressing improves bonding, but it can expand melt flow. Expanded melt flow increases surface coverage. Surface coverage increase reduces softness again. Each adjustment introduces trade-offs. Without a system alignment, circles of correction begin. Film structure influences retention behavior. Ink formulation influences optical strength. Powder selection influences melt volume. Press settings influence final texture. Softness and vibrancy are system-level outcomes. They cannot be guaranteed by film specification alone. When system limits are understood, expectations stabilize. When expectations stabilize, disputes reduce. In DTF printing, a soft print does not mean inferior color performance. It usually means material presence has been optimized for comfort. Color intensity and softness are balanced through system control, not isolated adjustments.